we can share the data set with all the people who are working in this domain. So this you some people might be familiar with the with our this KYL app. So here we just need to select the location, the available location here, and like we have the options for the state, district, and tehsil. So, like, just you need to select your state district, and tehsil in which you are interested to see the data or work on the work on the area. So, let's say we have a Jharkhand, Dumka, and Masalia. So we just select the location and go on download layers page. So here through this you can like download the data set which we have made available to the public. So just to give you a better sense of what these data sets are, so we have a like layer of terrain. So for first, so we have built some algorithm for the terrain classifications. So we get the satellite data and produce a raster for the terrain. So here you can like turn on and off the layers. So let's say we have the terrain raster here. So here you can see the raster and we have the 11 classes for it. Like each pixel is a class, which you can see here. And like all the U-shaped valleys, broad flat areas. So
Yeah, so maybe just to give you a better sense of what these datasets are, so maybe we can show that PPT, right?
yes.
Where it is. So yeah, so this is an algorithm that how terrain is classified and generated for each pixel. So basically what we do is we check the neighboring pixel of each pixel and identify, classify whether that pixel is at the bottom of a V-shaped valley or a U-shaped valley or at a ridge or at a local ridge. So basically there are total 11 classes in which we have classified this raster, and then we have vectorized it on micro watersheds. So we have made 4 clusters. So these are the 4 clusters in which we have mapped these 11 classes to. So yeah. So basically here, when we do vectorization, we are doing it on micro watershed ID. So here micro watershed ID is an index. So we have other layers as well, like rainfall, drought, that too are available on micro watershed ID. So maybe Kshitish, you can show that GeoJSON or
Yes.
JSON micro watershed.
So basically, the micro watershed can act as our data structure. So each data structure have some points in it for that area, which describe that area. Like the point by points, I mean the rainfall, what is the precipitation for that set of area, or what is the ET, what is the groundwater level. So these are like defined on a certain unit. So that unit we call it as a micro watershed. So you can see here in the hydrology, let's just turn this off and in the environment. So see, we have this my MWS layer, like this hydrological variables layer, which has the data for the precipitation, groundwater, and everything else. So let me show you the GeoJSON for it. So you can like download the GeoJSONs from here and so in the GeoJSON, you get the polygon of each micro watershed, and in the properties, you get the time series. Like this is the annual time series data for that particular micro watershed. And as you can see, there is like data for the delta G, ET, and precipitation, runoff, well depth, etc. for that particular year. And also there is some net values like net change values also in it, and what is the area of the micro watershed. And to refer this, how the this we have assigned some IDs to the micro watersheds. So these IDs are like common throughout all the layers that we have, so that you can like it act as a primary key. So for this primary key, we have like the MWS data structure, which has all these properties in it.
Maybe you can show that microwatt structures in it.
The- So through this tool, you can download all like there are also several available datasets. So we have these drainage, remote sense water bodies, CLART. So these all datasets are available on the micro watershed level.
Most of the vector layers are available at micro watershed level, and rasters are available at tehsil level. And we also do have this Pan India GE app. So from here, we have published few data sets that we have available for Pan India. So you can download them or use them directly in Google Earth Engine. And we have mentioned paths here on the sheet. It is available on this GE app. So yeah, you can explore this. Uh, so maybe we can tell a bit about our infrastructure, right? Uh, yeah. Yeah, I hope this is visible to all, right? This PPT.
Yes, it is visible.
Okay, okay. So we think of our infrastructure in terms of four layers, right? Uh, at the bottom, we are pulling together and also creating many new layers using machine learning on satellite data, such as to track land use and land cover change over the years and change in forest health, health of water bodies, tree species, etc., etc. At the next layer, we build many indicators, based on these data sets that can give a hint of on specific stress factors in different landscapes, interactions between multiple system, etc., etc. Then these indicators and data sets can be encapsulated in the tools that partners in our network are building, such as this Commons Connect application, which is meant to be a tool for communities to understand their landscape, identify good sites for forest restoration, tree plantation, farm pond sectum, etc., etc. Then on KYL, Know Your Landscape, that Chiti was just showing. So uh, it is a dashboard which is primarily meant for government department or CSOs to plan resource allocation based on specific needs in the area. Similarly, we have Jaltol, which is meant to assess the impact of water security of different kinds of interventions, uh, and for innovations for anyone to think of new use cases and use the available data and algorithm to solve new kind of problem. So this is that layer. Then finally, we are trying uh, that these outputs can be integrated into various government schemes and programs, and including market initiative like carbon credit, and lead to a quick action. Yeah. So this is how our infra is built. Uh, by my infra, I mean what this is what core stack is.
So I'm just taking it over. So basically, it's core stack is not alone built by us. So that's how this work. I just wanted to show you the process. So uh, okay. So first of all, we got a problem statement from the field. So we usually go to the field and we figure out a problem statement what we want to solve, and then it will fed into the next layer, which is the technical methodology. So there are two different kind of layers. One technical methodology, another one is software engineering. The technical methodology is mostly cared by the research team of Dr. Seth, which is mostly the students from IIT. Many of them are on the calls. So these technical methodologies developed by them, they code them, and then they again hand it over to our team, engineering team, where we convert all of this methodology, technical methodology into the product. And then we again take this to the field and we do testing and then again solve all the issue. And then again we take this to the field as a pilot. And first pilot, and the pilot is done by the various organizations, and we are partnered with them, and then final data set is data is taken out for the use. So that's why why it make it so complex that it's distributed among lots of the team, and the backbone of this is mainly the research and methodology team who do the first primary level of thinking and converting them into a technical document. So that's what I want to.
So, so, so let's say we also provide Excel as like Excel sheets. This data Excel is for Jamui, like Bihar, Jamui. So we provide the data on the like as I said earlier, like we have the MWS ID. So each MWS has certain properties. So all these data sets are provided for a particular MWS ID. So as you can see in the aquifer vector here, we have a UID column, and for that UID we have all the data sets which are available. So here also like so we have all the layers data presented in this Excel sheet on MWS IDs. And like let me just show you the MWS JSON also, like which I had shown earlier. So see, we also, like I said earlier, we also had these time series data. So we have certain static data and dynamic data. So by dynamic, I mean like these data we update yearly on the yearly basis. And by static, I mean the data set like terrain data. So like so terrain, these data are mostly static data because terrain like don't change in short span of time. So these are like kind of static data only, and the dynamic data is updated on some defined year, like defined time. After some defined time, like we update the Narega data mostly after 6 months, and we update these precipitation ET and delta G values yearly. We also have a fortnightly values also available with us. So it is also like updated on fortnightly is also updated like yearly. So these both data sets are updated regular like on yearly basis. So you will find the latest available data in the layers which we provide.
Okay. So we also build a geospatial stack index for all of these layers. So it mostly provide you the detail of about that data set. So we recently published the stack specs for all of these.
Yeah, so for example, this is the URL where you can visit this stack specs website of ours. So here we have listed down all the states. So for example, let's go to Jharkhand, and then this is the list of districts. So Dumka, then these are all tehsils. So under this is the stack spec of all the layers we have, most of the layers we have. So inside it, we have two type of layer like raster and vector. So in vector layers, you can see when you open, you can see the description that what this layers is about and what are the columns in it, right? Description about those columns. and you can download these layers from here as well. Similarly, for raster layers, so let's say LULC. So again, here's a description about this layer, the classes in it, and then you have styles to, to identify each pixel. So that's here. So Nizari, you want to add anything in it?
Yeah. Am I audible?
Yeah.
Yeah, cool. So, yeah, basically, stack specs are a way to describe any kind of spatiotemporal data set. So, in this case, we thought that because we have a few thousand layers across different blocks and different data types, it would be good if there was one single place to be able to see all this kind of metadata. Right. So, and obviously we have additionally added certain metadata such as layer descriptions and column descriptions, which we didn't have until then. So, as to help. So, as we can see that, I mean, at Core Stack, we sometimes host some external layers such as admin boundaries and stuff. In some cases, we modify layers such as Clart and stuff, and sometimes we compute a layer from grounds up, such as LULC. So, whether our layers suit your use case or not can be checked through the metadata that is available, whether the classes make sense, whether the methodology and the data inputs and the availability for the years is of relevance. So stack, with implementation of stack specs on our data, we are trying to attempt that. So yeah, I mean, there are different kinds of specs for raster and vector data. And also with this, it's an easy way to download the data. You can click on the links to download, and you can either download a GeoTIFF if it's a raster, and on a vector case, the GeoJSON. And similarly, you can also download the style files right away from the assets. So basically, so it's a single place to be able to know about the data and even use it. So yeah, and yeah, that's it, I guess.
And one more thing I would like to add here. So as I told earlier that most of our data is indexed at microwatershed IDs. Then we have one more ID that is village ID that we use like for data like admin boundary and Narega, right? So then we fetched those villages from Shrug data. So yeah, we have that index as well.
Okay, thank you, Aman. So basically, we are looking at core stack as a larger data structure, and where MWS and MDWS is mostly like index. So we are also envisioning a nested kind of query to the data structure where you can do like figure out some kind of terrain and on the MWS, and you will be able to fetch it. So our vision is to build a larger data structure based on the MWS and village ID. We can also join both of them. So that's all about the data set. And mostly our data set is calculated in a similar fashion. Like we first generate the raster by using some algorithm, and then we do the vectorizations, and then we publish those data sets. So again, I am coming back to our backend architecture. All of these compute happen at GE side. So we have a backend application, a small backend application, which is largely depend on the Django based architecture, where uh, this is our repo, which we will share all of this information on the Stack channel as a Discord channel as well as over email after the call. So on this this repo structure is very simple. So we have one component defined, which is a compute component, where we can feed any compute module defined by any methodology. So this is the very similar structure where anybody can develop any compute module and put it inside it compute. So that's how we calculate all our data set. And this is this is the script part. This is the data GitHub repo part. So it is already on the GitHub. I will share the information with you. And many of our data set is available for pan India, but many of our data set we calculate on the tehsil level. So right now only at location we generated is available. So if anyone wants to request for any location, we have a link on our KYL dashboard. So this is if you want to. So if you do not found your location in drop down, you can request for it. So we have automated pipeline through which we generate all of these data set for that particular location.
So what we are trying to say that we have generated layers at tehsil level. So we have covered around 200 tehsils as of now. But if any tehsil that for which you want to generate the data, generate these layers, you can put it on this form that Kapil just showed, and we will receive an email and we'll generate layers for that tehsil within a day or two. So yeah.
Okay, yeah. So that's all about the data set. So we talk about the data set, and we will also share the manual with you, our technical manual, where you can check the detailed methodology, how we calculated all data set, what was the input, and what was the source. We will share this over the email or Discord channel. Now I am coming back to the second layer, how we can access it. One way is by using the KYL. Another way is we expose some public API where you can access dataset by using that API. So for accessing that API, first step is to generate the API key. So for that, we have a admin dashboard where you can register and generate your API key. This is our admin dashboard. You can register and log in into it. So then there is a way to generate the API key where you will hit this generate API key and you can use this API key. So we wrote a notebook, a example notebook to plot the water balance for a particular area. So basically our admin detail is based on SOI. So the main thing, you can feed any latitude and longitude and get the details related to the state, district, and block. So the first step involves just send the lat long to this API and then get this API will return the state, district, and block. So one API, when you share the lat long, it will return you state, district, and tehsil. By using tehsil, state, district, and tehsil, you can get this data and plot. You can utilize those data sets. So that's what all, and we have lots of API. So you can check our redoc documentation. We will share this over the chat, or so there are many of dataset API available which you can use to explore the dataset and play with it. Okay, so I'm taking a bit pause here. If anyone have any doubt, please do ask.
Can we deploy it locally?
Yes, so in our next community call, we will cover that, how to deploy it locally. So that's on the agenda. So we have an predefined installation script where you can go and hit the install and it will deploy it. And
It
this
keeps
stack,
asking for APIs like AWS and WhatsApp and all those things.
no, I think it's just asking for some. So we will drop a default configuration. So what happened, this entire stack data stack also contains some functionality related to WhatsApp API. So there are some predefined settings. So we will drop a default setting over there, which will reduce these kind of issues.
I think that
Okay,
is
thank you.
already available in our Git repo.
So we will cover this, how to install it in our next coming session. It's depend on mainly two things. You need a GeoServer local installation and you need Postgres. So not very much complicated. So we'll cover this.
Okay, thank you.
Any other question? Okay, thank you. So I am moving to our, so we will be also developing another set of APIs, a water bodies API, where what we haven't released it yet, but I just want to share you with you all a brief of that API. So what it will accept, it will accept again state, district, and tehsil, and you will get a response as a set of water bodies in that area with their indicators. So what we are trying to build is we are trying to build a water visualization dashboard where some kind of activity happen on that water body, like desilting, and building some we are building various parameter on that. So these are the dashboard we are building. It's in the phase of building, where this first section shows this is the water body where that desilting happen, and on the top it is showing the LULC, and these are the indicator related to the precipitation and water availability during Rabi Kharif season. So this black line represent it as a intervention area. So we can compare intervention here, sorry. We can compare pre and post intervention, what variation happen and what is the basically impact. We also calculated ZY, zone on influence around that water body by some algorithm, and obviously if you want to understand more about the algorithm, we can definitely share these information with you. And inside this ZY, we calculated the cropping intensity. So in water body zone of influence, what was the cropping intensity, and also drought and these NDVI time series. So in this highest peak is showing
2 peaks means double cropping.
so 2 peak is showing the double cropping, and so we generally calculate the cropping intensity from them, and we also showed the terrain for that particular white. So since we already showed our all data, terrain, rainfall data is compute on the micro watershed, and the index is micro watershed. So this boundary is micro watershed boundary, and this is the drainage line. So we will be soon releasing it and its API, and we will make this available.
We are also working on, Pan India Water Body Atlas. So we'll have all the, some unique IDs for each water body for Pan India. So that will be very helpful for, further using them in further calculation and other things.
Okay, so and I just wanted to share you, we on next community calls, we will be discussing these water bodies API, local copy installation of that, and we will be also taking question answer question about any doubts from this session. We will share all of these information on Discord and over email. And also we will be discussing about one of our application. So this we will do in upcoming session, which is used for the watershed planning in the field. It is an Android based application, Commons Connect, and also we will be releasing a WhatsApp chatbot where people can share their demands, and community engagement API where they can come and create their community, collect various data from the community by filling some form on the WhatsApp. So that's on our future roadmap. So we will be
Invited talks also. Invited talks also.
also we will be planning to arrange some planning to take on board some expert and arrange some invited talks in the upcoming session. So please do subscribe do connect for upcoming sessions also. So again, I am taking a pause here, and if you guys have any doubt, please ask anything we can share.
Kapil sir, just a suggestion. Maybe it will help in summarizing, like you mentioned, some of the data sets have data at watershed level. Some data sets have data at tehsil level, and then what kind of features are available for each data set. So that kind of and so basically what I was trying to say, that maybe this whole information can be summarized in few sentences so that everyone can get a better sense of the entire
Yeah.
session.
Thanks, Ashima, for bringing this up. So, uh, what we do is currently we are generating data for tehsils, but we are intersecting those tehsils with micro watershed boundaries. So our data is at micro watershed level, right? So what we did is we have pan-India micro watershed boundaries. We clip those on tehsil level because there's a scaling issue. Some algorithms are very heavy to run. So the tehsil is the maximum we released for them as of now. So yeah, we have micro watershed level data, but we generated them on for tehsils. Yeah.
What is like temporal frequency of collecting this micro watershed data? Like, do the rainy season microshed data
So
are those like
this is basically this is kind of static data.
okay? So the dates are like the dates or years are available for when it was collected, or like a month level or date level, or which kind of. So
So
what I mean,
you are talking about micro watershed boundaries, right?
yes, like in rainy season, these are different than in summer season, to my understanding. Is that correct?
Maybe Raman or anyone from the students can tell that.
Okay, so we'll take this question. We'll answer this question because mostly this is the technical specification developed by the student. So we'll discuss and come back to you in the next session how it is actually calculated and how uh, this rainy season will make an impact. Right.
Okay, thank you.
Yes, Prabhakar, we can use QGIS desktop, so you can download the file. And so what do you mean by integration? You directly want to fetch it from G or the source? Well, obviously, you can download and use it on the QGIS. Okay, we're talking about what is the URL. Yes. So we will share the URL with you. Let's figure it out. I will share it URL with.
So all of our layers are hosted on GeoServer. I'm not sure whether you'll need credentials to use that on QGIS. If not, we can share that. But if it needs credentials, then I think we need to create a user or figure out something how we can share that data, right? But yeah, layers are available on GeoServer, and that's an open URL as well. We'll share that URL in the Discord or email group.
Hi team. I wanted to ask if we can get, so static data is static, which gets updated in a yearly basis. What about the everyday changing data like rainfall, in this portal, does it get updated on a yearly basis or?
No. So static, when we talk about static data, it is the data that won't change for, years, like terrain won't change for, several years or decades, So this is the kind of data we call static. Dynamic data is like rainfall and drought data. We are updating that at, annual level. So for each year, for example, we are in 2025. So we have data till June of 25 as of now in our data sets. So it is not updated, daily basis or fortnightly basis. We, do an exercise every year after June or July to update all of our assets.
Understood. So basically, rainfall data is available till June 2025.
Yeah.
Post that, if we want to get, is there a API? Like, how do we get that, or we have to wait for, let's say, end of the year
So
till?
there are two options: either wait or all of our code is, open source. So you can, use those algorithms to generate data on your own.
Okay.
So all that data is available in our Git repo, and all the data structure are mapped with files in a table in README. You can see that.
Got it. And the temporal resolution also for data like rainfall data would be on a daily basis for a 25-kilometer grid by IMD, whatever is the basic data structure.
So we are using JAXA for rainfall. So I think that is at 2-3 kilometers something.
Okay.
And so we are using JAXA for that.
Understood. Thank you.
Any other question? So yeah, thank you very much for everyone for joining this call. So as a core stack, we want to do it together. We cannot alone develop all the data sets. So idea of building this core stack is to building it together with all of your help. We can integrate more data set into it. We can improve our calculation. We can improve our capacity. So that's the whole point of doing this community call, so that we can build this together and something which is useful for the entire community. They can use it and anyone can use it. So that's the whole motive behind this call. So I'm again extending my thank you for everyone. Okay, so another question, can we also get the resolution for all the data set along with their source?
So Shreya, for that, we have details in our technical manual. We'll share that, but that is available at our website as well. But we'll share it in Discord channel.
So we'll share all of these URLs and technical manuals and on our Discord channel and on the Google group. So you can access all the information about. So technical manual have all the sort of information, how it is calculated, what is the resolution, what is the method. So entire information is there. So I will share it immediate after this call.
Yeah. Any other questions?
Yeah, thank you very much. Thank you all for joining this call. Looking forward you for next week. We'll share the agenda for next week. Most likely we'll cover the local installation first, and then we'll share the agenda soon. Thank you very much for joining.
And please be active on Discord channel and Google group, and do ask as many questions you can. Yeah, it is better for us as well and for you as well. Yeah, thank you.
Thank you.
Thank you.
Yes.
Thank you. Thank you.